We're going to talk about different wave shapes that you can get using NB drumcrow. So we got Pit Orchestra here doing the sequencing. It's coming out of crow output 1. That's going into the disting NT, running an oscilloscope, and then going into the sound card, which you can hear the oscillator going. If we go to parameters, and we go down to wherever your script has the different NB voices, drumcrow 1, we go to that menu, and then we have all of the different parameters here for drumcrow. Let's see if we can get a longer decay on this amplitude. So I usually use the amp envelope here for that. The amp envelope frequency, lower frequency. There you go, makes it a bit easier to see the waveform. First things first, you have different synth shapes here. So we have crow gives you different shaping functions to use to go between voltages. So for this variable saw ASL model, what we're doing is we're going down from one voltage up to another voltage, up and down. And we can set the different shape that we use to get between those two voltages. So if we had a linear path between the two, we have this waveform coming out, which is more of like a triangle waveform. Sinusoidal path between the 2 points. A logarithmic shape, which will be quickly up and then settle slowly. The opposite of that is an exponential shape, where it's slowly rising and then quickly at the end. Now is it will immediately jump to the next voltage and hold at that value. Wait will wait at the current value and then jump at the end, so it's the opposite of now. Over will overestimate the target voltage and then settle back down to it. Under will underestimate the target voltage, settle back down to it. So it's kind of the opposite. Rebound implements a bouncing ball algorithm, so it will go to the voltage and then bounce a few times and then settle at the target voltage. So you can see that notches in the waveform there as the bouncing ball starts bouncing. Let's go back to linear here. So we have the triangle waveform. If we go down to the pulse width here, let's go negatively. We can take that point and then put it to the left. So now we have a sawtooth waveform. Similarly, if we change this pulse width and go all the way to +1, we can get a sawtooth waveform the other way. And then, if we go all the way -1 and then use an LFO modulating the pulse width, we set that to 2. We can go from -1 to +1 on the pulse width. Let's see what that looks like with different shapes here. Go back up to linear. We have a sine that's pulse width modulating. The logarithmic shape, we can get actual pulse width here. When using now or wait, which is a square wave, at +1, you'll have a constant positive voltage. So if the pulse width is just constantly +1, it'll just be a constant positive voltage. Similarly, it'll be constantly a negative voltage as well. Here's over, here's under, here's rebound. So that's cool. Let's turn this off, set this back to 0. And we turn modulation for the pulse width from the LFO down to 0 as well. That's cool. The amplitude of our signal right now is between +5 and -5 volts. The amp is currently modulating the amplitude of our signal, but you can use other envelopes, such as the LFO or this note envelope down here, to also modulate the amplitude. But I like using separating the envelopes for different purposes. That's why I labeled them amp. So this amp is modulating at 1, which will be positive 5 to negative 5. Crow can output positive 10 volts to negative 5 volts. So, if we increase this amplitude, right now it's between positive and negative 5 to 2. This will be from positive 10 to negative 10. We're requesting that. However, the Crow hardware will clip the bottom half of the waveform, so you get this asymmetrical overdrive distortion. And you can see that on our oscilloscope here, where the bottom half kind of clips out at negative 5 volts. We can increase this further to request a higher voltage, say that'd be 15, I think. And this would be 20, I'm pretty sure. Positive, negative 20. And you can see the top of our waveform also is clipping out at maximum amplitude a bit. See what that looks like on different shapes here. Everything kind of gets square wavy. See, only one half of the bouncing ball is there. So that's one way to get a bit more overdriven sound out of the oscillator. Let's look at Bitcrush now. So Bitcrush uses the quantizer on Crow to quantize to a certain scale, which we select using Corvus. When Corvus is set to off, it's just the chromatic scale. So for this Bitcrush value controls the voltage range that an octave takes up. So at 0, that means that the bitcrusher is off. Anything that's 0 or below 0, there will be no quantization occurring. However, as we increase this value, at 1, this will be 1 volt per octave. So now this signal is being quantized to 1 volt per octave currently, and we're oscillating between negative 5 and positive 5 volts. If we go up to 2, that means it's going to be 2 volts per octave. You might be able to hear it change. There it is. Let's go up to like 10. So now this is 10 volts per octave, so we're stretching. If we take a voltage range of 10 volts, we quantize that to the chromatic scale. Should be like 12 different stair steps, and you can see the stair steps occurring here. We can increase this way larger to any value we want. Let's go up to like 60 here. Now you get some stair-steppy patterns. So you can think of this as stretching a quantization scale across a voltage range. If we change this from off to a different crow species, and these are all custom scales I've put in here that we use to quantize to. So depending on the quantization, depending on the volts per octave voltage range, we take this scale and apply it to that range. And you can see the waveform dramatically changed in value here. Change in shape, I should say. Let's see what different shapes do. Towards the right are louder shapes. I should say more noisy, chaotic shapes. Towards the left are quieter shapes. The first two species are major and minor, and then pentatonic as well. And then it starts getting more customized as you go. So as I said before, if the bitcrush is at a negative value, there's no quantization happening. But we can modulate into a positive amount. So now the amplitude envelope is pushing this value from an off value to a on value. So it might start quietly, or it'll start in the... Yeah, it'll start distorted and then end clean. Because it'll go from a high value down to a low. We can do the opposite also, where we can... Yeah, now we're modulating negatively, and so we're going from a negative value and ending to a positive value, which will add more bitcrush over time. Let's transpose this down a bit. Let's add in our pulse of modulation again. Let's use that LFO. Wiggle that back and forth. Let's flip our bitcrush modulation depth. I'm gonna turn off modulation to bitcrush. Higher values, you'll get a lot more square wave patterns. At lower values, this is a lower voltage range, so you'll get the quantization happening in a smaller range, so you get these little spikes to the signal. Let's turn this off for 1 second. The amplitude limit before the bitcrush limits the amplitude going into the quantizer. So whatever amplitude that we have in our signal, so right now we're at positive -5. That means our maximum amplitude that we can request into the signal is positive -10. So if we set this way high, the maximum amplitude that we're requesting is going to be positive -10, because it's limited here. However, if we set this to 20 or 40, you can see that we start really clipping the signal by we're requesting a really high amplitude signal going in. And that's pretty cool with the bitcrush, because then we can just we can kind of emphasize the lower fundamental frequency, while the bitcrush is kind of acting on the higher end. Example. So now let's change this from 40 to 5. So now we're only it's only outputting positive -5 into the bitcrusher. It kind of just sends this overdriven signal into the bitcrusher or not. This goes down to 1 or 0 if you want to mute switch quick. So what Mutate does is it will take the scale that we're quantizing to, and then start to modulate the values inside of that scale. So instead of just a scale from, say, the chromatic scale would be the notes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or the major scale, which would be like 0, 2, 4, 5, 7. Those are like the MIDI notes, if you will. you can actually get different arpeggios or different melodies that you want. So you can go from like 0 to 7 to 5 to -2 to 12 to 14. You're right, and you can just kind of jump around, and so it will always take that scale that you defined and quantize it to this voltage range that we have here, this for the bitcrush amount. But then if you mutate from that scale, so 1 will be the normal value. If you mutate like positively, then you'll hear it change and modulate the values inside the scale. I'm gonna turn off the pulse width to illustrate this. Pulse width modulation off. There we go. Now we just have a normal linear waveform. Let's start the bitcrush. This is static. Let's go voltage range about 4 volts. You can see that change down there. Now if I change the mutate value, you can see the wave shape start to change pretty dramatically as you adjust the mutate back and forth. If you go from -1 to +1, let's use the LFO to modulate back and forth. So if we're going from -1 to +1, we get this wave table type of sound by flipping the scale back and forth. The scale that we're quantizing to, the values of that are flipped back and forth. Let's do a bit more depth. So if we go mutate to -2, and then we set the LFO to +4. There you go. So sometimes the scale can quantize to values above the voltage range that we're requesting. So even though we're only the amplitude limit right now is positive -5 volts, the quantizer can go outside of that value based on the mutate and bitcrush amounts and the scale itself. So just be aware of that. Let's use a limit of +20, let's say, and then let's increase the amplitude going into our quantizer. So now we emphasize kind of the lower fundamental because we're kind of overdriving the input, but we're still getting some distortion out of it, so you can get some more emphasized bass this way. Just turning the amplitude limit down to 5 to hear how it sounds. We're going to go down to like 1. Let's turn the bitcrush down to like 2. Yeah, now it's only a little bit of bitcrush. Usually like that at a higher value. Back down to 10, let's set this back down to 2. Start modulating some things, like pulse width with the amplitude and below. So the pulse width down to like -6. Start modulating that with the LFO too. Let's set the note envelope to loop. So now we have another LFO, which is using this other envelope, cycling envelope to loop. Let's set that frequency down to like 1-ish. Set the symmetry of this will be to 0 to get half and half positive attack and release. The curve down to 0 so it's a linear shape. Start modulating things with it. Just kind of turning randomly right now. You can modulate the bitcrush down to a value past 0 to turn it off. Just like a little bit. Maybe turn it way up. One thing to take note of is that if you use a synth shape that is logarithmic or exponential, there's a special function for the mutate parameter. So what this does is it actually modulates the temperament of the quantizer and crow from a value as close as I can get to around 0 to only positive. So it just bounces towards 0 and then always goes positive. But you can hear what that does to the signal here by if I set bitcrush to a higher value, say 4. Set mutate down to that 0. There we go. Now I have the LFO modulating mutate from 0 up to 3.4. I set this down close to 0. You can hear it kind of glitch out. And at straight up 0, it shuts off completely because you can't quantize anything at the temperament 0.